Let us solve problem in the concepts of physics textbook. Figure shows a small body of mass m placed over a large mass m whose surface is horizontal near the smaller mass and gradually curves to become vertical. The smaller mass is pushed on the longer one at a speed v and the system is left to itself. Assume that all the surfaces are frictionless. Find the speed of the larger block when the smaller block is sliding on the vertical part. Find the speed of the smaller mass when it breaks off the longer mass at height h. Find the maximum height that the smaller mass ascends. Find the distance traversed by the bigger block during the time when the smaller block was in flight under gravity. First, we find the speed of the larger block when the smaller block is sliding on the vertical part. Here we have given velocity v to the smaller mass m so that it moves in this curved part. When it reaches at the maximum height h, it becomes vertical. At this point, this block has two component velocity. One is vertical component velocity, that is we are taking as y, vy. Another one is horizontal component velocity, vx. With this horizontal component velocity only, this block, this mass capital M also will be moving together. So to solve velocity of the larger block, what we are going to do in the sense here, we are going to take the concept is known as conservation of momentum. By taking conservation of momentum, according to conservation of momentum, initial momentum is equal to final momentum of the system. Initial momentum is equal to final momentum of the system. So listen here, initial momentum of the system is equal to final momentum of the system we are taking. Initially this small block m only is in motion. This bigger block is not in motion. So that initial momentum is m into v. That is equal to final momentum. This momentum we are taking along x-axis. So that momentum, conservation of momentum along x-axis we are taking. So that initial momentum along x-axis is equal to final momentum along the x-axis of the system. So initial momentum along x-axis is mass of the block, small block into velocity v is equal to final momentum. In final case, this both body together moves in horizontal direction, so that both bodies masses are together. We are taking m plus m into v into x component velocity. So x component velocity is equal to m into v divided by m plus m. So with this velocity, this bigger block moves horizontally. So bigger block moves horizontally with velocity is equal to small m into v divided by capital M into small m. So the velocity with which the bigger block moves horizontally is equal to small block mass into velocity, initial velocity divided by total mass of the system, that is capital M plus small m. Next, second question we are going to discuss. Find the speed of the smaller mass when it breaks off the larger mass at height h. That means at height h, when it leaves the smaller mass, what is its velocity we have to find. So here at maximum height, this block small m has two velocities. One is x component velocity, another one is y component velocity. These two component velocities we have to find out. Then we have to take resultant. That resultant only gives the velocity of the smaller mass when it flies away from this larger block at height h. Already we found that horizontal component velocity is equal to small m into v divided by capital M plus small m. Next we have to find vertical velocity. To find vertical velocity, let us take conservation of energy. By taking conservation of energy concept, we can find vertical velocity, then we can get resultant velocity of the block small mass m. So we are going to take conservation of energy. According to conservation of energy, initial energy of the system is equal to final energy of the system. Initial energy of the system is equal to final energy of the system. Initially, listen here, initially this complete block, this larger block is rested, this smaller block only is in motion, so that it has only kinetic energy. Finally, when it leaves the at a height h, this larger block has kinetic energy and the smaller block has kinetic energy along x direction as well as in y direction. And also it has potential energy also, and also it has potential energy. So by considering this all, we are going to solve this sum. So here initial energies of m v square. Final energy is kinetic energy of the block. Kinetic energy of the block, if you take, that is of m, capital M, into horizontal component velocity square. Horizontal component velocity is small m into velocity divided by capital M plus small m whole square. And we have to take kinetic energy of this block also. This kinetic energy of this block, if you take off into m into total velocity, this is v dash square. Let us assume this velocity as a v dash. This velocity we taken as a v dash. And at this place, it has potential energy. That potential energy, let us take as mgh. Let us take potential energy at this point as mgh. By simplifying this, we will get velocity of the smaller block as v dash, velocity of the smaller block v dash at the maximum height h. Now what we are going to do here, see here, this first we are multiplying this equation by 2, and we are cancelling this small m. By multiplying this equation by 2, multiply above equation by 2 and cancel the small m. If you cancel the small m, what happens means here, this equation v square and m into m v square divided by m plus m, because we are cancelling small m in both sides the equation, plus v dash square and plus 2gh. We need v dash only, so that v dash you keep one side, remaining all bring to another side, so that v dash square is equal to v square minus m v square divided by m plus m whole square and minus 2gh. Now we take common v square. By taking v square common, and 1 minus m divided by m plus m whole square minus 2gh. And we are taking m plus m whole square. This is m square plus small m square plus 2mm will come. So 2mm and minus mm will be cancelling, so that v square into m square plus small m square plus m divided by m plus m whole square. This minus 2gh is there. Here velocity dash whole square is there. So v dash whole square, take square root, so it will become velocity. So we are getting velocity of the small block at the maximum height, at height h, as v square into m square, square root of v square into m square plus mm plus m square divided by m plus m whole square minus 2gh. Altogether square root is their answer. This is the velocity of the smaller block when it reaches the larger block at height h. Let us solve third part. Find the maximum height from ground that the smaller mass ascends. See here, when the smaller mass at maximum height of the larger block, it has horizontal component velocity and vertical component velocity. So that when it leaves the block, this larger block, it moves as a projectile. Here, this is the maximum height h. But we need to find from the ground the maximum height traveled. We need to find, that is h dash. That means h dash is equal to h plus h. We have to calculate. First, let us calculate capital H and we add by small h, so that maximum height reached from the ground we can get. For that, to find maximum height, we have formula is vertical component velocity square divided by 2g. Vertical component velocity square by 2g. To find vertical component velocity, already we know that complete velocity, this velocity we know that. From this we can get what is the formula for vertical velocity, means total velocity square is equal to vertical component velocity square plus x component velocity square. Now let us substitute here total velocity, this velocity let us substitute here. By squaring this one, we are getting m square plus small m square plus capital M and small m divided by m plus m whole square into v square. This is the total velocity square. This is the total velocity square. This minus 2gh is there. So minus 2gh is equal to y component velocity square plus x component velocity square. Already we know that x component velocity is equal to capital x component velocity square is equal to small m into v divided by capital M plus m, this whole square. So by substituting this value and bring to left side, we are getting y component velocity. Y component velocity square is equal to m square plus capital M small m, capital M small m. Now this m square plus mm plus m square m small m square divided by m plus m whole square into v square minus this vx velocity square we are bringing left side, that vx velocity is m into v into m plus m. So m square v square divided by m plus m whole square minus 2gh is equal to y component velocity square. Now this here we are, if you multiply this m square by m plus m square and v square, this term will be cancelled. Hence vy square is equal to, now vy square, this is the vy square is equal to this. Here take capital M common, so that capital M plus small m divided by m plus m whole square into v square minus 2gh. Now by cancelling this capital M plus m, this denominator capital M plus m, we are getting vy square is equal to mv square divided by m plus m, mv square divided by m plus m minus 2gh. And we know that maximum height formula is y component velocity square divided by 2g. So that we are getting answer as mv square divided by 2g into m plus m minus h. And we want to find the maximum height from the ground, So we need to calculate maximum height from the ground. From the ground is we have taken as h dash. So h dash is equal to h plus h, plus h. So h plus h is mv square divided by 2g into m plus m minus h is, this is the capital H value, and plus h. So this h we are cancelling, so that h dash we are getting as mv square by 2g into m plus m. So this is the maximum height reached by the smaller block from the ground. Last one, find the distance traversed by the bigger block during the time when the smaller block was in flight under gravity. So now we have to find the bigger block moves horizontal distance during time of flight of this smaller block. That means we have to take here horizontal acceleration of this block is 0. Horizontal velocity into time is known as distance traveled by the bigger block. To calculate this one, horizontal distance traversed is, we are taking this vertical velocities here. Using this vertical velocity, we can find time of flight. We can get time of flight. So horizontal distance traveled is equal to horizontal velocity into time of flight. We know that the formula for time of flight is equal to twice the vertical velocity by g. Now we know that vertical velocity is equal to, vertical velocity we got here, mv square by m plus m minus 2gh. So capital M v square by m plus m minus 2gh. By taking this LCM, so mv square minus 2g into m plus m into h divided by m plus m we are getting. And horizontal velocity with which the block moves is small m into v divided by capital M plus small m. By substituting all the values here, we can get horizontal distance traveled by the larger block. So we are going to substitute m into v divided by m plus m, and time of flight is 2 into vy. Vertical velocity we know. Vertical velocity is m v square minus 2g into m plus m into h divided by this vertical velocity square. Actually this is vertical velocity square, so that we have to write in square root. This vertical velocity square, so that we have to write in square root. Here we are getting m plus m square root, all together square root we are getting, divided by g, because time of flight formula 2 into vy by g is there. Now see here this m plus m, here m plus m power 1 by 2 is there. So that this is 2 into m into v square root of mv square minus 2g into m plus m into h divided by this g into m plus m power 1, this m plus m power 1 by 2. So that m plus m power 3 by 2, capital M plus small m power 3 by 2. So this is the horizontal distance traveled by the larger block during the time of flight of the smaller block under gravity.